Hey everyone, this is Mr. Molo for lesson 5-5, solving equations by graphing. So I'm going to tell you right now that title is a little misleading because I would not graph any of these. What it says here, like when they show you solve 2x minus 1 equals negative 1/2 x plus 4, in this first example, they're really telling you that they're both already set up in y equals form for you. So they're set up nicely for graphing. It's not that they're hard to graph or impossible to graph. It's just that I think algebra would work a lot faster. So if you see them set up like that, they're telling you that they're both equal to y. So hey, here's a nice graph that you can do it for. And then even if we look at the second example, they even want you to solve it algebraically and then solve it graphing. This way you can kind of see which one you like best. So I'm going to kind of do that with some of the examples here. Again, I like solving it by algebra better. You want to go ahead and graph it. That's by all means, go ahead and do that. If we look at like example 1 here, this is one example about why I wouldn't want to graph it. I have 2x minus 7. And we can see there's no 7 on this scale. Each thing goes by 2s. So I'm not going to graph number 1 here. I'll solve this one algebraically. So I have 2x minus 7 equals negative 2x plus 9. So I'm solving for x. So I got a couple steps here. Step 1, get my x's together. So I'm going to add 2x to each side. You could have subtracted 2x from each side. That's perfectly fine. I like to do it where I get my x's to be positive. So now I'm left with 4x minus 7 equals 9, and then I have a minus 7, so I'm going to add 7 to each side. So I'm left with 4x equals 16. Divide each side by 4, and you figure out that x equals 4. So not that different from what we did before when we're solving two-step equations like that, or variable on each side, something we've already done. This one, since it actually has some nice numbers here, I'll show you how to do both algebraically and graphing on this one. So I'll graph 3x in black and x minus 4 in red. So if I'm graphing y equals 3x, because remember that's really what it says, there's nothing at the end here, so we're going to start at 0. Okay, it wants us to go up 3 and right 1. We can't do that because up 3 would be off the graph. Remember, instead of up 3, right 1, we can go down 3 and left 1. Down 3 and left 1. And that's going to give us the same points. Okay, and then to graph x minus 4, that means I'm going to start over here at negative 4. And that means my slope is up 1, right 1. So that means I'm going to go up 1, right 1, up 1, right 1, up 1, right 1. So then if I look and see where they cross here, looks like they're crossing down here at that point right there, and x is negative 2 at that point. So if you really like graphing, you can do it that way. By all means, I'm not going to mark it wrong if you do a graph on there and get that, get negative 2 that way. Or if I want to do this algebraically, I have 3x equals x minus 4. Same thing as the other problem. I'm going to get my x's together. So I'm going to subtract x from each side. So I have 3x minus x is 2x. That equals negative 4. Divide each side by 2. And negative 4 divided by 2 is negative 2. So there's my two ways, in either green where I'm solving it using algebra, or in red and black where I'm solving it with graphing. No matter what you see, each answer I get is negative 2. Okay. 4 gets a little more complicated here just because it adds some parentheses. Otherwise, it's pretty much the same thing. So I have negative x minus 4. And then I have these parentheses. So 3 times x and 3 times negative 4. So 3 times x is 3x. 3 times negative 4 is negative 12. Otherwise, we're pretty much looking at the same thing. So remember, when I do these, I like to get my x's together first. You can do it where you get your numbers together first. Again, it doesn't matter as long as you're doing all the steps eventually, just not in the same order that Mr. Molo likes to do them in. So 3x minus x is 2x. And then I have a negative 12 over here. So I'm going to add 12 to each side. And we have negative 4 plus 12 is 8. So 8 equals 2x. Divide each side by 2. So we figure out that for this problem, x equals 4. If we were to graph it, then the two lines would be crossing at 4. Okay, and then when we get down to 5 and 6, something silly happens again. So I have negative 3x minus 5 and 6 minus 3x. So this is one reason why I would get all my variables together first, because then we're going to solve this problem one step faster than if we got our numbers together first. So if I get my x's together, So I'm going to add 3x to each side. We see something weird happens. Negative 3x plus 3x is 0. They cancel out. So I'm left with negative 5 equals 6. Well, that's not true. Negative 5 does not equal 6. That is going to be a no solution. If we were to graph these, remember a no solution problem ends up looking like two parallel lines. So here, if I start here, I'll do this one in black. It might be a little difficult to see because, again, these are going up by 2's, and I have, of course, odd numbers of 3 and 5. So I'm going to start at negative 5, and I'm going to go up 3 and left 1 because it's a negative 3, so I should be going down 3 and right 1, and then up 3 and left 1. So my line looks like that. And then I'll do this one in red again. So I got 6 minus 3x. So I'm going to go down 3 and right 1, down 3, right 1. So we can see that those lines are parallel. They're never going to touch, so that's why it's a no solution. And then you could probably assume what's coming next. So I have 7x minus 14. And then if I distribute my negative 7 there, I get 14, or negative 14, plus 7x. So looks very similar, and that's because they are. They are exactly similar. They are exactly the same. I have I subtract 7x from both sides, and they end up with negative 14 equals negative 14. And that is true. Negative 14 does equal negative 14. So then my solution is all real numbers or infinitely many solutions. Everything works for that point. Okay. And then the only other part where this lesson gets harder is we'll throw in some absolute value equations for you. So remember, with absolute value equations, we're going to have two equations usually. So one will solve normally, and then the other one will have to have one set equal to 0. So these usually take a little bit more room. So let me write it out. So one problem we're just going to solve like normal. I'm just going to take off the absolute value bars. So 3x equals 2x plus 10. I'm going to subtract 2x from each side. So those cancel out. 3x minus 2x is just x. And so my first answer, I'm left with x equals 10. So that's one answer. And remember, for absolute value equations, I need to make one equation negative. So I'm going to multiply one equation by negative 1. For this problem, I'm going to do the left side because there's only one thing over there. So it's easier to change one thing than to change two things on the right side to multiply that by negative 1. So instead of 3x, I'm going to do negative 3x equals 2x plus 10. Otherwise, then the math is pretty much exactly the same. It's a positive 2x, so I'm going to subtract 2x. Except this time, negative 3x minus 2x gives me negative 5x, not 1 like it did before. So now, when I divide both sides by negative 5, I figure out my other answer is negative 2. So my two possible answers for this are 10 and negative 2. Okay, I'm going to look at number 8 there, copy it down. So I have x minus 1 equals x plus 3. Okay, so remember one equation, we're just going to copy it down just as it is. Don't change anything. And for this one, it's kind of weird because what happens to my x's? They cancel out. So I'm left with negative 3 or negative 1 equals 3. That is not possible, students. Negative 1 does not equal 3. So for my first one, I'm going to get a no solution. And then for my second equation, let's multiply this right side by negative 1. So my left side is going to stay normal, x minus 1. And then my right side, I'm going to multiply everything over here by negative 1. So negative x, or x times negative 1, and 3 times negative 1. So I end up with negative x minus 3. So I changed both things on the right side to negative 1. The first problem, I chose the left side. Again, it doesn't matter which side you're choosing. You'll end up with the same answer either way. So now I'm going to add x to each side. So now I have 2x minus 1 equals negative 3. So it's a minus 1, so I'm going to add 1. So I get 2x equals a negative 2. And then divide both sides by 2. And we figure out that x is negative 1. And then the last one on here, I have x plus 4, and then 2 minus x. So same thing, first problem, I'm not going to do anything different. Just write it out normal, get my x's together. So this time I'm adding x to each side. So then I get 2x plus 4 equals 2. Subtract 4 from each side. So I get 2x equals a negative 2. Divide both sides, and you figure out that one answer is x equals negative 1. Then when we go to do our other one, so this time I'll multiply, we'll say the left side by a negative 1. So instead of x plus 4, it's negative x, and then distribute that negative 1 to the 4 as well, minus 4. And then you'll see the same thing happens in this problem that happened last time. When I add x to each side, my x's end up canceling. I'm left with negative 4 equals 2. That's not true. So we get a no solution for that side. So we just have one answer there, and it is negative 1. Also, just to point out, there are some problems on the homework that look exactly like number 2 that we did. They're even going to have it graphed for you already, and then they're just asking for what the answer is, and the answer is just where those 2 points are crossing. So when you get to those questions on the homework, we didn't really do an example of them in here, but when they're asking for questions like that and they're already graphed for you, don't waste your time doing the algebra. Just look and see where the points are crossing on there, and you'll know, like, oh, the points are crossing there when x is negative 2, so then the answer is negative 2.